If we take a look about what's happening within the White House, which is a blueprint for AI Bill of Rights, there's 4 key things that is being discussed right now. Number 1, the identification of who trained the algorithm and who the intended audience is. Number 2, the disclosure of the data source. 3, an explanation of how it arrives at its responses. And 4, transparent and strong ethical boundaries. So we have to have the systems to be able to govern these because the penalties could be severe.
Hi, you're listening to The Secure Developer. It's part of the DevSecOps community, a platform for developers, operators, and security people to share their views and practices on DevSecOps, Dev and Sec collaboration, cloud security, and more. Check out devsecon.com to join the community and find other great resources.
Hello, everyone. Welcome back to The Secure Developer. Thanks for tuning back in. Today, we're going to embark on a bit of an AI security journey, which I think will be fun and interesting. And to help us kind of kick that off here, we have Ian Swanson, who is the co-founder and CEO of Protect AI, a company that deals with AI security and specifically runs MLSecOps, which is a great kind of information hub for defining what is sort of AI security, or at least what is MLSecOps, and we're going to dive a lot into that. So Ian, thanks for coming onto the show.
Yeah, thanks, Guy. It's awesome to be here. It's a great podcast. Really excited to talk about the security of ML systems and AI applications.
So I guess just sort of kick us off and context a little bit. Can you tell us a little bit about who you are, maybe a bit of background, and I guess kind of how did you kind of get into AI security in the first place?
I've been in the machine learning space for 15 years. It's been an area that I've been incredibly passionate, in. I've had multiple companies in machine learning. I had a ML-centric fintech company called Symmetrics that I sold to American Express. And then I started a company called datascience.com that back in 2014 was setting the groundwork of what is today known as MLOps. And that company was acquired by Oracle. Today, I'm the CEO of Protect AI. And Protect AI is all about security of ML systems and AI applications. And we think the time is now. In terms of why I'm passionate about this space, well, prior to starting Protect AI, I was the worldwide leader of go-to-market for all of AWS AI machine learning. My team worked with tens of thousands of customers. And I've seen the rapid rise of adoption of AI and machine learning across all key functions within a company. And so as we think about the evolution of adoption of AI, yes, how do we get these models in production? How does it drive digital transformation? How do we make sure that we de-risk them from ethics, trust, and bias? But what about protecting it commensurate to its value? If the CEO of JP Morgan Chase, Jamie Dimon, in his shareholder letter is talking about the rise of adoption of AI with hundreds of applications within that bank, then we better make sure that we protect it commensurate to its value. And I think that moment is here today. That's why we started to Protect AI. And it's another reason why I'm just so passionate about this space is I believe in the potential of AI, but I also understand the pitfalls within ML systems and AI applications.
Yeah, absolutely. I totally relate to the urgency around this, especially with almost like unnatural rate of adoption due to both usefulness on one hand and maybe competitiveness on the other, thrown in some hype. And a lot of these systems are going in so much faster than past sort of notable technologies, even sort of clouds and containers and sort of other capabilities that relative to their prior trends were adopted quickly. Let's sort of dive in, we're passionate about it. Before we dig into MLSecOps, like you chose to call it MLSecOps, not AI. Do you want to sort of share a quick view on how do you separate AI and ML?
It's kind of funny. A lot of people use it interchangeably. Where ML, machine learning, is a subset of AI, and you can think of deep learning as a subset also within the AI category. The reason why we focused on machine learning, at least from a messaging perspective, is a little bit of the core persona that we're working with that is at the center of operating ML systems. And what I mean by that is the role of an ML engineer. So kind of think about parallels within software development, but on this side, the person who owns the CI/CD, the software development stack, if you will, for ML systems is an ML engineer. And we think it's the ML engineers, they own these systems. They also own the responsibility of, yes, getting models into production, but they need to think about how do we protect those models? How do we secure those models? How do we make sure working with the data scientists, practitioners, the line of business leaders, that we are de-risking those models? So we really wanted to pay homage to that persona. and also to this space and this skill set within machine learning. Now, you use machine learning to build AI applications, right? So that's definitely down the stream, but we think it's really critical for us to focus on the machine learning development lifecycle.
That's useful, I think, both from a practicality perspective and kind of general definitions. I guess I indeed oftentimes sort of think about AI as the value proposition, eventually produce me some artificial intelligence, please, with machine learning being, maybe the primary means of achieving that. So with that, let's sort of dig into this sort of MLSecOps. So, that's a new term. I've sort of been part of the DevSecOps. I have my sort of love-hate relationship with the term. Help us a little bit with some definition. What is MLSecOps? And maybe let's sort of start breaking it down.
MLSecOps stands for Machine Learning Security Operations. And it's the integration of security practices and considerations into the ML development and deployment process. Now, why is it different than DevSecOps? And it goes back to what I was talking about previously, that the ML development lifecycle is different than software development. Software is built on requirements provided during the first phase of SDLC. But machine learning, the model is really built based on specific data set. Software systems likely won't fail once they're deployed as long as requirements are not changed. That's not the case with machine learning. The underlying characteristics of the data might change and your models may not be giving the right result. And it's dynamic. Machine learning is, again, not just about the code on that side, but it's this intersection of data, the machine learning model building and artifacts and the pipeline that, yes, turns into code and a model that gets deployed, but it's dynamic. It's constantly learning. The data is changing. And so why, again, a new category is machine learning development lifecycle is just different than standard software development lifecycle. So that really goes into why is the need for MLSecOps.
Before we kind of go there a little bit, so it sounds like you're sort of emphasizing not just sort of the different tools of like, look, I need to be able to inspect this or inspect that, but you're sort of describing a different nature of those types of systems, not just almost like the predictability, or it's just a different form of agility. Instead of it might sort of change with every request that flows through the system or the data come in. You find that to be more important or more substantial than the specific tools or sort of phases that might be introduced into a development lifecycle?
There are some different tools, that is used in the ML development lifecycle. There's also different users here. We have data scientists, ML practitioners that might not be well versed in typical or best engineering practices. And so if we think about what are the differences, there's 4 that I can highlight: management, GRC, development, and audit of building, and why this is different than software development. So we think about management. Your traditional code concerns might be on like change states, whereas in the machine learning world, there are dynamic conditions that can equate to new or different threats. On governance, risk, and compliance, we have rules, we have terms, in software development, where a lot of GRC for machine learning is on use and impact. And so that's another kind of risk profile. In the development, you might be working in proxy environments as you're building software, but a lot of machine learning practitioners are working in live systems. So think about that. Like, we're using a tool, for example, let's say a Jupyter notebook, in a live system that's connected to super sensitive data, pip installing open source packages, exploring that data, building these experiments on that side, all before you're checking in or committing any code. And it might be in an environment that, again, is live.
A constant sort of deployment in production, or sort of developing in production, coming along. A customer complained about something, you come in, you SSH, you change the production system. I think everybody has some battle scars from that type of surrounding.
Yeah, absolutely. And this built into the rise of ML ops as a category. And we really saw ML ops rise in the form of enterprise software solutions and adoption between the years 2014 and 2018. Now, when you go and talk to any of the Fortune 500, Fortune 1000 companies, they understand that term. They have tools, they have solutions there, but they also have many different flavors of ML ops tools. It's not necessarily the Wild West, but it is still somewhat shadow IT. It's a black hole where the ML development lifecycle is not well known or thought about as it relates to security and risk. And that's where we think that there's an opportunity for further education. Hence, going back to the question, which is MLSecOps and what is MLSecOps? And we think that that's a new area that people need to be informed about, understand the differences, the risks, but also the opportunities to more harden their systems and build better AI applications.
And what was the 4th again?
Yeah, the 4th is audit. And so as we audit software, it's oftentimes down to like version controls. If you think about machine learning, it's a lot around provenance changes. It's understanding the different elements that are within that machine learning development lifecycle and understanding provenance change perhaps on a training data set on that case. And that is super critical in terms of what is the end artifact. The end artifact being a model that goes into production or an AI application. And so on the audit side, there's also just less transparency. There's less systems in place for these audits. A lot of it is held within the headspace, if you will, the ML practitioner that's building these systems. And so there's a lack of attestation, there's a lack of provenance, and a lack of controls here. And that's an area that is different as we think about security within the machine learning development lifecycle.
And that last one is maybe one that we're sort of a little bit more familiar with when it comes to sort of new technology. So that's like that sort of fourth one is a bit of a typical type of problem that exists when a new technology gets introduced, which is practices are not awesome and they need to be evolved. While sort of the first three are sort of a fascinating view that come back to your definition of MLSecOps, which is it's a system in flux. It's a system that is constantly changing because it learns from the data and it is guided by data versus guided by specific instructions, which makes it a lot harder to assess, a lot harder to govern, a lot harder to version or kind of understand how differences happened in a milestone fashion. You need to adapt your security practices to something more continuous. It's interesting because I'm kind of reflecting on sort of DevSecOps and its narrative to the degree that you're describing now. It's sort of the next level of speed. If before we had our sort of annual releases or sort of semi-annual releases, and from there we went to continuous to agile, maybe for internal releases, and then to DevOps and sort of continuous deployments, and security struggles to keep up because of the pace of change. You're almost saying like in ML, you shouldn't even consider these sort of audit gates and those sort of rates because you have to think about something that is naturally continuous and fluid. Otherwise, you're probably never going to be at pace.
You're right that it's always changing, always evolving, super dynamic on that side. Audit is still going to be a massive category within this space, especially with new regulations that are coming out. And perhaps we could talk about that a little bit more later. But some of the last, just to kind of frame this picture again on the ML development lifecycle, it starts with the data. You explore, you validate the data, you wrangle the data, you create new data sets, training, tests, validation data sets. It then turns into the model engineering, the feature engineering, the hyperparameter tuning to how do we evaluate the model? How do we package the model? So we serialize it maybe in Pickle, Onyx, other formats. We then serve that model, deploy that model. We have code for integration testing. We monitor, we log, and oh, by the way, we start the cycle all over again. So that's that last point of like, it's dynamic. It's this living almost artifact, on that side as it takes in inference and inputs. It's creating new data. And so from an audit perspective, we have to understand those changes. And we need to be able to, yes, keep a record of that. We have to have true attestation. We have to have true provenance. But we also have to make sure that we live in this dynamic environment. And so it's a really interesting space to be in. And as we talk to these ML engineers, it's what they're working with every single day. Hence why we're focusing on ML and the ML SecOps is, yes, an end artifact, is an AI application, but it's really this stack of the ML development lifecycle that we need to harden.
Great points. And we're going to dig in. I keep holding you from sort of breaking up MLSecOps for us on it. We're going to get to that in a moment. Maybe one other sort of bit of context, and maybe we'll use that as we go through it, which is that I'm sure everybody listening, they sort of fall into different categories of use of AI. So fine, there's the ones that are not doing that right now. Maybe they're listening just because they want to learn. But I guess in my mind, I've always sort of thought of there's the model builders, people that are actually straight up, either they're building the model or they're training the model. They're actually properly generating the model. So it's sort of one class of organizations. Then you're going to have another class of organizations or applications that are fine tuning. And so especially in the world of GPT or sort of more general purpose, that seems to be a growing possibility. And there's probably a larger portion of organizations that might be doing that than ones that are building a new GPT or sort of a new trained LLM. And then there's the ones that are just using it. I'm just sort of introducing some chat interface. Maybe I gave it some access to some of my data, but I'm just sort of embedding it into my applications of my data, but I'm not overly maybe it's a lightweight fine tune or anything. Is that a legitimate way to sort of classify uses of AI? And does it change substantially the sort of the type of threats that one might need to be worried about?
Yes. To look at that, you have companies that are builders, you have companies that are adopting, you have companies that do both, on that side. And so when I was the worldwide leader of AI machine learning at AWS, we had AI services that were just kind of out of the box, if you will, algorithm services for personalization or fraud detection. And then we work with companies that would adopt our MLOps tools like SageMaker and be building their own models. But within the problem, or let's say surface area of both those options, it's really a supply chain question. Are you at the beginning of the supply chain or towards the end of the supply chain? If you're a builder, you're adopting open source technologies, prior research, you're building models throughout every single stage of the development lifecycle, and you have to understand that complete supply chain. If you're an adopter of AI and you're working with vendors on that, you need to say, okay, how is this being built? How can I trust it? What is the data that it is trained on? And if it's my data that's being trained on, then that's part of my supply chain that I need to think about. And so I think you're absolutely right that there are companies that are building a lot of their own IP, but usually on the backs of prior art. And then there are companies that are adopters and buyers of solutions like ChatGPT. And threats, are across both. But I will say, throughout my career in this space, a lot of people have said, like, how many companies are actually building their own models? How many data scientists are there and ML practitioners? How big are these ML teams? And I've been at organizations where we have seen that we've had tens of thousands of customers, large customers that have teams of not just dozens of data scientists and ML practitioners, but hundreds, and in some cases, well over 1,000. So there's been a lot of ML building and AI adoption prior to just what we've seen since January 1st.
Yeah, no doubt. This is just sort of the recent craze. I guess in my sense, people have switched to believing in AI thanks to ChatGPT. So AI has been around, has been growing, has been sort of significant in our lives for a while and has been picking up momentum. But I think what ChatGPT has done is it's captured people's imagination. And for good and bad, definitely a lot of bad on the security lens of it. It has fueled a certain pace that today we have to accept as reality and sort of see what we do about it. So I think those are very good points, and to say, don't discount the ML actual kind of engineering, actual consumptions. And if you're more on the consumer side, then you still need to sort of have an ability to assess the thing that you are consuming. Also, I guess my sense from conversations is everybody's feeding at least some amount of data into it. You're probably not just sort of putting a straight up sort of a ChatGPT pathway in your application. You're probably trying to modify its behavior in some capacity. I guess in that context, let's sort of indeed dig in. So how do you break apart the MLSecOps sort of world?
So first, let's understand here the importance of machine learning, and then I'll dive into the 5 key pillars of MLSecOps. So an example I like to give is that if you're a financial services company, institution, machine learning is used every single time money is moved around that financial services company. And so think about that. It sits at the heart of a company. It's one of its most critical functions. And so now we want to break down what we are calling the 5 pillars of MLSecOps. And it is so important. Number 1, supply chain vulnerabilities. We need to understand the supply chain. What is being used in building these ML models, these AI applications? Number 2, the model provenance. Understanding a true bill of materials, if we will, for what we're using in terms of the ingredients, the recipe of the model. Number 3, governance, risk, and compliance. Number 4, trusted AI, fairness, ethics, bias of models. And number 5, perhaps a little bit more future state, but adversarial machine learning.
So I think those are the sort of useful titles, and some sort of sections feel a bit more sort of natural to me, but maybe let's break them down given the sort of the criticality. By the way, it's, maybe just as an analogy, you talk about companies that already revolve around AI. I also find that in many companies, even if they don't revolve around AI, there's a temptation for the chat interfaces, even in that sort of specific world, there's a temptation to create slightly all-powerful proxies, or rather enable the sort of the chat system to be able to access a variety of APIs. So even if the company doesn't end up intentionally revolving around AI quite yet, or maybe they don't know it, they end up exposing some critical information, critical actions, kind of under that mantle or that sort of the opportunity of creating a brand new user engagement model through that chat. So either way, I think we're fairly aligned that it is critical. Let's sort of dive into each of these five. It sort of feels like they almost go also from like a good software anchoring that people would find it easy to understand to things that are sort of a bit more sort of domain specific. So start with supply chain. So how does that manifest in the world of ML?
As we think about the supply chain itself, again, it's not just code. It's not just open source packages that are used within the models. We have to truly understand the supply chain as it relates to the data, how we build these models, and yes, the code. And if we think about this in analyzing and creating, if you will, a bill of materials, and kind of tying it to Executive Order, 14028, that bill of materials in the machine learning world is different than your typical SBOMs. And so, as we both know, there are multiple organizations that help set standards for SBOM, CycloneDX, SPDX. They've actually come out and said there needs to be a new version of a bomb. What they're saying is an AI bomb. We call it a machine learning bill of materials. They're calling it an AI bomb. Now, why is understanding the supply chain so critical within this space? Well, it's one of the most important, or say more risky, if you will, threat surfaces within ML development. Most machine learning and AI is built off the backs of prior art, not necessarily original art. And so data scientists, ML practitioners are commonly using open source packages, frameworks. They are diving into foundational models as the basis of what they're building, and also utilizing a lot of academic research papers that are out there. So they're leveraging a lot of prior art to build their own IP that powers functions within their business. And that's part of the supply chain that we need to understand, along with the data sets that are being used and how those data sets are being used in every single model and changing over time.
Yeah, interesting. So it has the sort of the regular software components. And I guess IP, to an extent, has always been also something that you should understand which IP comes into your system. But it was a lot less algorithmic. It was kind of rare. It was really, typically the conversation has been a lot more about license. Am I allowed to use this? Which I guess also is true here. But you're saying, I guess for these kind of models you're consuming or such, does that sort of slip a little bit into that model provenance side? Or is it just like fundamentally we find weaknesses in these models, so you should keep that bill of material to say, well, I've used whatever Llama, or I've used Stable Diffusion and some versioning element of them to know that there was a weakness there that I have to upgrade, just like you would a software component.
Let me give a couple examples on the supply chain and then build that bridge into model provenance. Within the supply chain, as I said, people are using prior art, typically open source libraries, packages, frameworks, foundational models on that. But they're also sometimes doing it in tools, as an example, that are a little bit more, as I said, shadow IT, or not in the purview, if you will, of typical security organizations. So I'll give an example, a Jupyter notebook. So notebooks in general are used probably 90% of ML projects. They're used at the beginning of the ML development lifecycle and experimenting, exploring data, testing out some simple models on that side. But they're also many times in live systems with access to super sensitive data. And as they install these pip install open source packages, they're then at the mercy, if you will, of the IP licenses, as you called, are this permissive licenses or are they not? But also what vulnerabilities, are within these libraries that are being used. And then beyond even vulnerabilities, and we'll talk about this a little bit later, from a trusted AI, should I even use this? And we've found some super interesting vulnerabilities within the machine learning development lifecycle and common open sources being used. One is MLflow. MLflow is a super popular open source software that is used in many, many development pipelines for machine learning. MLflow is also inclusive of a model registry. And so just recently, there was a CVE that NIST scored 10 out of 10. Now, why did they score it 10 out of 10? It was complete LFI, R5 from a standpoint of I can get a system access if I want to, one, steal IP, so steal the models. Two, I can even do code injections. And so think going back to that example when I say a bank is leveraging machine learning and every single time money is being moved around that organization, if I can go in there in a super simple exploit that lives within the supply chain and get access to do code injections, alter and change that model, that is a very high level risk for these systems. And that's just one example of the supply chain. Again, the supply chain is built on oftentimes not original art, but prior art in the ML environment. And that's why it's so, so critical to understand and to be able to assess the risk within it.
Yeah. So I understand. And that does sound, though, very much, it's sort of in many ways, it sounds similar to what might compromise your sort of build system or might compromise your applications because you're using it. And I guess you're saying it is augmented or sort of amplified even more when you consider this developing in production type element, because if you did, maybe there's a shorter time window between the time that someone might have sort of downloaded or used sort of an untrusted component and the time in which an attacker could exploit, which maybe in software you have, I guess, more opportunities to sort of find it downstream, which puts more emphasis on things like early gates and detections versus saying, fine, maybe someone can download it as long as I kind of find it when it's being built. Maybe I'm okay taking the risk on development environments and things like that. Does that sound correct? So like fundamental importance, don't forget about it, as it is in sort of software. You have to address this. You have to be mindful of the models that are being consumed because they in turn, they have certain weaknesses probably in items. We'll dig more into that. But also remember that where you're developing might amplify that risk even more. So you better be on it.
Where you're developing, what you're using, what is that IP? What are those packages? What are these foundational models? The bottom line is I need to understand these things.
What are the sort of the primary tools that one might use for a supply chain? Is it sort of the same old supply chain security, right? Is it sort of Snyk and its ilk? Like what's another gap there that's missing that those tools would not still satisfy?
I think the main gap is visibility into these systems. And really what visibility is anchored to is a bill of materials. That's the biggest gap, is we need to build the bridge into these systems, into these pipelines, into this process so that we can do what we do best in software development. But it needs to first start with, as we are talking about the supply chain, I need to have visibility into it. Oftentimes, when a machine learning model is built to ready for deployment and it goes to AppSec or it goes to some team for penetration testing, it's really just the end model itself, the scoring function, maybe the pickle file, like what's going into production. But there's a whole series of steps in the ML development lifecycle prior to that artifact that we need to have that bill of materials, that visibility into, so that we can apply tests. And those tests and those rigor might be, as you stated, Snyk and others, in the world. It's just building the bridge into this area that is not seen and giving that visibility across these systems so that we can apply best practices within security.
Understood. And I think for completion here, and I know we're sort of talking substance, and I appreciate this, but I think Protect AI is one of the tools that might help you a little bit in this domain, right?
Yeah, we focus on bill of materials. I think that's the foundational item in terms of where you can build, for example, visibility, auditability, and security on top of.
Thanks for that. We'll kind of leave it to the listeners to sort of go off and learn more at their interest. So cool. So supply chain, super important, fully understood. And it's just sort of a fun fact, I guess, is, when Llama was open sourced by Facebook, the weights were not open source, but they were leaked subsequently, which allowed, of course, the model to be used. And that was sort of a big deal. In sort of a similar vein, maybe like an example that sort of helps the penny drop for some folks is the weights might be what eventually kind of gets into deployment models and all of that. And so at that time, those are not that important, but whatever manipulation, whatever sort of attack or whatever compromised third-party components might have happened, that would have been earlier. It's the weight generation that is the sensitive part here, and where a supply chain attack might have been dramatically impactful, maybe even sort of SolarWinds level. So I hope I'm kind of getting it correctly.
Yes. And that's where a good pivot to the model provenance. So perfect. The SolarWinds hack of 2020, like that served as a stark reminder of the importance of ensuring transparency, accountability, trustworthiness of software supply chains. And so as we get into model provenance, the second pillar of MLSecOps, it's really about understanding, yes, bill of materials, but attestation of these models. It's understanding who built them, how they built them. So again, going back into the supply chain and connecting the dots of all these systems. I've seen large enterprises, I won't state the names, that there's typically what's called a model card or a document that somebody approves within the line of business as they are putting a model into production. These documents can be a few pages, to dozens and dozens of pages, but it's an artifact that lives in that single moment of time. And as I said, the difference within the machine learning development lifecycle is it's incredibly dynamic and it changes. And so as we think about model provenance, it's yes, understand the bill of materials and the supply chain, but we need to do that in a dynamic way that is constantly keeping attestation, versions, snapshots of the model so that we can replay these. We can audit these models, we can understand the risks, and we can fix them quickly. So model provenance is super, super important pillar within MLSecOps.
Can you give us maybe an example of something done right and something done wrong? So like what problem might occur if you didn't properly cover model provenance? And maybe to sort of counter that, what practice, I guess, would have helped you avoid that problem?
So from a healthcare use case perspective, again, I won't give a name of a company, but we have seen examples where there's even been rogue internal actors working with, again, super sensitive healthcare data. They've been able to, as they have access to that as an ML practitioner, siphon that data off as they build these particular models. But because there is no provenance, there is no attestation, there is no understanding, if you will, from a code level perspective of who created these models, what they're doing with the data, how they're creating these models, and it's only being looked at the end result, which is the model itself, is the organization wasn't able to capture this quickly. They weren't able to play it back once they understood that they had an internal rogue actor to see, okay, what did they do? What did they build? What were the ingredients that they had access to? And so it's not always external threats. In this case, this is an internal threat. And it goes back to, again, some of the differences of the ML practice, live systems, access to super sensitive data, building incredibly powerful models that are used internally. And we need to be able to understand who and how they're building these models and be informed of how we stop particular risks like this. So that's like almost that's a GDPR, example, but also tied into this new space of model provenance and understanding all this connective tissue here.
What's an example of a practice that would catch these types of issues? Or it's probably like too broad to get into detail, but maybe in the example you sort of said, what practice would have helped prevent that?
I think the easiest thing is that we have to have attestation through every single step of a model build, all the way through from the data we're using to the model that's being deployed and understanding all the in-between parts, of how that model's been tuned and the software that's being used in creating that model. Only then can we actually audit these systems. And if we have the ability to audit these systems, we can create rules and we can create policies on top of it. Policies that can check for irregular behavior in this case. And as we can check for that irregular behavior, because we have true provenance and understanding of the system, we can stop it or we can quickly react to it.
It sounds also akin a little bit to the world of observability on it. It's sort of know if your system is diverging from it. So on one hand, just trying to kind of translate this into DevOps terminology, on one hand, you're saying it's very hard to achieve immutability that we might aspire to in software because the system is naturally a bit more fluid. But you want to still aspire to that a little bit, make sure that when changes do happen, they're sort of properly attested so that there's a log of that having happened. And then alongside that, something along the lines of observability to sort of know that you've digressed and that it's not working the way it used to work, right? Or that it was sort of planned, which is very hard because the models are very complex. And so defining what normal is quite complex. But is that kind of about right in terms of analogies to operating, kind of running ops systems?
Yeah, absolutely. And I would probably just anchor on this point of, as we think about model provenance, we link it to audit. Can we audit these systems? Do we understand these systems? If supply chain is visibility, we need to build to have audit ability. And to have audit ability, you have to have model provenance. And I'm right now stating that the vast majority of enterprises do not have visibility and auditability. And that's a key area of risk as we think about threats on this space.
Well said. That's probably like a pretty good tee up into your sort of third pillar there of GRC. So tell us a bit more about how that is specific MLSecOps.
Governance, risk, and compliance, the third pillar of MLSecOps. As we think about the differences, again, of software development and ML, GRC for machine learning is not just about rules and terms, it's about use and impact. So when you look at new policies, new regulations that are coming within this space, whether it's the EU AI Act or even the most recent discussions, at the White House, people are raising their hands and saying, we have to be able to have policy to understand the risks within these systems. So if you have the first two pillars where I can have visibility, I can have auditability of the supply chain, I have provenance, now I need to be able to go in there. I need to be able to govern these. I need to be able to understand the risk of these systems. And I need to take a look at it from a compliance lens, especially tied to new regulations that are coming out.
So the assessment of risk, I guess, is a new view on what risk is, right? Risk in the deployed system is mostly around the sort of ease of exploit and the sort of implications of whether someone would sort of pilfer some data or would maybe be able to sort of enact actions. I'm kind of grossly oversimplifying over here. Does it boil down to the same fundamentals in risk when it comes to AI? Are there other facets of GRC that we need to be mindful of?
I think what's interesting about this space is, and it's kind of anchored by the point of new policies that are being created, is this use and impact. We have to understand the end user and the decisions that are being made by these AI systems. If we take a look about what's happening within the White House, which is a blueprint for AI Bill of Rights, there's 4 key things that is being discussed right now. Number 1, the identification of who trained the algorithm and who the intended audience is. Number 2, the disclosure of the data source. 3, an explanation of how it arrives at its responses. And 4, transparent and strong ethical boundaries. That's a little bit different than when we talk about your typical software. It's more anchored on use and impact and the understanding of how it reaches the decisions that it does to make sure that it's not biased, that it's ethical. So we have to have the systems to be able to measure these, to be able to govern these, de-risk these, because the penalties could be severe. If you think about the penalties within GDPR, we just recently saw happened with Meta and fines on that. But there's going to be similar penalties if you look at the EU AI Act that's currently in draft, that's looking for final submissions in the next couple months to be able to put it into practice. And some of those things that have been talked about is a percentage of your global revenue is the penalty. And so GRC is rising to the top, at least within the AI space, as a critical area that companies, as they look at their investments in AI, they're having to build practices to be able to govern these systems and make sure that they are compliant.
Understood. And I guess from a practitioner perspective, if I'm a CISO and I indeed have my developers or there's AI being added, whether I like it or not, into my applications, what would be some key steps that I would need to do to get a hold of kind of the GRC practice, to level up my GRC practice to cover those AI uses?
Yeah. I think there's 2 key steps, external and internal. External meaning understand the new regulations that are coming, have clear definitions, create policies, create trainings, based on that. But there's a lot still in flux. These are new. I mean, the AI Act's in draft and development over the last couple of years. But what we're seeing right now in the AI Bill of Rights, like these are new movements, but they're moving fast. They're moving fast on the tailwinds, if you will, of AI adoption. So let's understand what's coming from an external perspective on policy. Internal, I need to get my house in order. I need to get my house in order from an understanding of this can no longer be shadow IT. This can no longer be a model that we just look at from an AppSec perspective. We have to truly understand, again, the supply chain, who built it, have a system of record, a bill of materials, so that we can connect the dots into the policies that are being created. And that house cleaning step is just now happening within organizations. And it's going to be a massive effort because it's not just on new models, but it's also on models that maybe they deployed a decade ago. They're going to have to go back and say, how was that built? Who built it? How was it making decisions? And capture all that logic. So this is a big house cleaning exercise, but it is incredibly important. And the only way that you're going to connect the dots to this external influences that are coming from these policies, these regulations.
So interesting. It sounds very similar to the security posture management, the whatever STAR security posture management type world, but it has another flair added to it. So for starters, you have to know what you've got. So where in your organization is AI being used? who is running it. And then subsequently, you need to go and maybe, unlike a cloud security posture management or even like data security posture management, it's not about just what's there. It's about what arrived, because what's there is not sufficient. You can't just sort of understand its journey from it. It's true for software as well, but maybe because of the behavioral aspect of AI, which I guess is an appropriate term, you actually need to sort of dig deeper. But probably I'd imagine that for most organizations, that first thing of just know what the hell is going on and where is it is probably plenty of work. Like if you haven't done any of it, that's probably a pretty valuable first step.
Yeah. I would add too that there are a few resources out there that can provide this, if you will, map or exercise to connect the dots. Gartner has been pushing forward the AI triism that focuses on model governance, trustworthy, fairness, reliability, robustness, the efficacy, and the data protection. So there's a framework that even Gartner has created that is helping their customers and the industry as a whole frame the problem and understand how to connect the dots. Another one was an open source initiative that I really like called Avid. Avid is understanding vulnerabilities within the system, but it has a taxonomy that is incredibly valuable. So the Avid taxonomy, as we look at it, focuses on security, ethics, and performance. And there's boxes within this taxonomy that now organizations can take back to their teams, their security teams, their ML engineering teams, and figure out how do we check the boxes across this taxonomy. And the third one is MITRE. So we all know MITRE ATT&CK. Well, the MITRE team actually said there needs to be a new version of ATT&CK for AI systems. And MITRE has created then something called Atlas. And MITRE Atlas is 100% focused on the ML development lifecycle, on AI applications. And it's taking a look at it in a framework that we, as people within this space, we understand, because it's layered on a similar framework of attack, where we look at reconnaissance, execution, collection, defense, evasion. And so organizations can use that again as a blueprint to say, okay, how do I get my own house in order so that I'm ready from a governance perspective for the regulatory, for the policy that is coming?
Super useful models on it. Just for those kind of seeking the spelling, Avid is AVID, and ML.org is the website for it. I'm assuming I've got to the right one. So great models and super useful because AI shapes everything it touches, so many aspects of it. You have to think about it adversarially from multiple different paths. So thanks for sharing those. Let's sort of continue. We're sort of going much deeper into AI land. We've sort of gone from 3 topics that are fairly well familiar to most security practitioners to I think the last 2 that are getting a little bit more hairy and a bit more sort of AI-ish on it. So let's move forward. What's the next one on the list?
Yeah, the next one on the list is trusted AI. And this is all about ethics, bias, trust. It's understanding, are we making the right decisions? Are these models acting in the appropriate behavior that we think that they should be? Are they not being discriminatory, as an example? Now, this can be a very difficult thing, to work with. One of my previous companies, datascience.com, we had an open source project called Skater, and there's been a bunch of open source in the space of how do we do explainability of a model. And if we can explain how a model makes decisions, then we can also understand if that model is being fair or if that model is being biased. And so I think this is an incredibly important pillar of MLSecOps, but it's also one that is a little bit ambiguous and it's tough to figure it out because it's about the model performance at an individual sometimes level to make sure that it's acting appropriately.
And do you perceive that, and talking to organizations, do you see it being placed under the security organization? Is that where it's landing in terms of, is the importance of it, I think everybody would agree, is very high. Is it falling under security?
I think we're actually seeing a lot more involvement in legal teams. The legal within organizations trying to make sure that they are helping from a brand perspective, that we're not doing anything that we shouldn't be doing. And eventually, as these compliance and new regulatory items come out, that we're working with our compliance teams to adhere to it. But as we get into this trusted AI, it's really about, can we be transparent? And are we able to provide clear explanations for the decisions? And that's what we're seeing in some of the White House policy that's being drafted as well. And so I think there are systems in place where the ML teams, the ML leadership teams, they own it. They work with their GRC and their legal teams to make sure that they have checks in place as part of their CI/CD process, that they are explaining how the model is coming to the decisions that it's making.
It's interesting to note that companies like TikTok, like Meta, companies in which both the AI and the trust in AI sort of been a topic of conversation for a good while, many of them did eventually merge the organization. They did put them under the same mantle. So it does seem like industry dynamic has moved it into a domain that has enough overlap. And maybe some of it is indeed thinking a little bit adversarially, thinking a little bit more about the unintended consequences, which is the domain of security.
I agree with that.
This is such a massive domain and probably a topic for many podcasts on its own. But if you were to try and tell someone, where do I even start when it comes to figuring out if your AI can be trusted, if you're doing okay over here, do you have a starting point for people to go to?
Yeah, the starting point is fairly simple, but yet hard to achieve, and that is explainability of a model. When you're building your own model, it's a little bit more attainable. You, again, understand the true supply chain. You're using your own training data on it. Where it becomes a little bit tricky is when you work with vendors that are supplying you the end AI application that you might just be integrating within your own software stack. And so on that side, I think the most important thing is asking the right questions. It's asking the right questions of how it was trained, how was it built, and then doing some effectively unit tests on the model. And so we see other solutions out there that are checking models for a category or something called robustness on that. And so we're giving it a lot of fuzzy data, or we're giving it outliers within this space, and we're just testing the model. Similar to how we would test any other software, we're going through a QA process to say, is it making the decisions we think it should? Do we understand how this model is built, the data that it's being used? And can we explain these decisions, if we need to our end users? And so it's building in that framework, building in these practices and these processes internal is the right place to start.
Yeah, you have to start by almost learning the questions on it. I do hope that certain tools come along and try to make it easy. I don't think this will ever sort of truly go away, but at least to understand pitfalls. I think there is a category of AI safety tools. I know of one company in that world called Lakera.ai. They just had this sort of fun prompt injection tool called Gandalf kind of make the rounds. So drew a lot of attention. They tried to do safety. I do hope there's going to be like a category of companies that try to help you just sort of know a bunch of sharp edges that you can test your model against, at least.
Yeah, this category is actually a little bit more well-defined than the security category of ML. And what I mean by that is, over the last 5-8 years, there's been a lot of open source, that's been shipped and developed. H2O as a company has been a leader as well in terms of producing open source in the realm of explainability. We see companies like Fiddler that have commercial offerings, to test the bias, fairness, explainability of models, and a whole slew of monitoring companies in this space too that have that as an anchoring point of their offering. So this is definitely a space that you can not only find, open source, but commercial offerings that can help a company get started and monitor these things over time.
Excellent. And under the kind of the mantle of explainability or safety, I guess, is probably the keywords to look for.
Yes, that's absolutely correct.
We're on to the last and probably kind of coolest name on the list, which is adversarial ML. Tell us a bit more about this fifth pillar of MLSecOps.
Yeah. Adversarial machine learning is super interesting. There's been thousands of research papers written just in the past few years. One of the most prominent researchers of adversarial machine learning is Nicholas Carlini. And he's been documenting research papers on his blog and the growth of those. And so why is this space interesting, and what is this? So adversarial machine learning is effectively the practice, if you will, of, can I manipulate a model? Can I fool a model? Can I exfiltrate information from a model, or perhaps the model itself, and can I poison a model? So as I think about these attacks are at the point of inference. And so if a model is publicly exposed, at this point, it's a clear threat vector, threat surface that attackers would have access to deploy these techniques.
And I guess the biggest challenge, there are a lot of challenges with this world, but one of the biggest challenges would be knowing that it even happened, right? Because a lot of times you don't fully understand, maybe back to sort of the explainability of the system, why a decision was made, but it's quite hard to sort of anticipate that if a data was poisoned, not just anticipate, but know that that has occurred. Is that a domain where there are nascent tools, or does that come back to the provenance?
It is a domain, but I think it first starts with prevention, then detection. So let's talk about the prevention side. So I'm going to give an example as it relates to extracting IP, extracting data, or in this case, extracting the model itself. So how that particular adversarial machine learning attack will work in theory is if I have public access to the model, I can hit that model at the point of inference many times, thousands of times, hundreds of thousands of times, throw random features at it to try to recreate the model to a lookalike model. Well, I'm talking about prevention. So how do I prevent attack like that? Pretty simple. I could put some throttling on the API, in that case. And so adversarial machine learning, I think, is a real category within the security of machine learning systems and AI applications. However, it's not always practical. It's not always generalizable or scalable. Simple defenses that we put within common practices like AI endpoints could stop many of these attacks. And so from a place to start perspective, it's making sure that we are doing the basics, if you will, and that we're not skipping any steps on the ML model, not only building, but also in this case, the deployment, of it.
Yeah, great practices there. Would you put, like we managed to talk about AI security for an hour and not say prompt injection? I did, I guess, when I mentioned Gandalf, would you put prompt injection into this category?
Yes.
Would
manipulation? I absolutely would. And that's where we've actually taken adversarial machine learning and leaped forward in terms of its practicality by almost a decade, if you will. So while there have been thousands and thousands of research papers over the last few years, those research papers are mostly concentrated on white room access, complete access to the model, understanding of the model to prove a point that it could be tricked, fooled, stolen, etc. But in the case of large language models and generative AI, we now have an AI application that's exposed to the user. And so that starts to really get into the pitfalls of generative AI. And those pitfalls of generative AI can have common links within adversarial machine learning, especially around prompt injection attacks. And so as we look at prompt injection attacks, it's, hey, can I create malicious content? Can I bypass filters? There's data privacy issues within it. And so absolutely, I think as we go through large language models, use cases like ChatGPT and others, we're going to see more of the rise of adversarial risks here tied to this category of adversarial machine learning at the point of inference.
Right. And we're kind of towards the tail end of the episode, so I won't go too much in depth, but for those who don't know it, prompt injection is generally indeed through, at least for LLMs and for natural language, it's the fact that a lot of times the defenses are actually kind of written as these types of language instructions themselves, or they're layered on top. And so you can almost like socially engineer the AI defenses or the LLM defenses so that it would take a different stance and therefore disclose information, share secret information in an encoded fashion, overcome whatever privacy or ethics or other constraints that have been put on it. And it's a fast growing world. It might be worthy of an episode of its own as we talk, because it is a growing in popularity thanks to the growing popularity of LLMs in general. So adversarial ML is really the new domain. It's less theoretical for things that are exposed to users, and for many AI systems, if you're talking about medical and all that, it takes quite an effort for someone to come in and manipulate the data at enough scale. But when you're talking about public-facing applications, when you're talking about browsing data, getting pulled into your LLM interactions, when you're talking about anything in which there's more readily available, I guess we've seen that in all sorts of manipulations, for instance, of Google's autocomplete and things like that, where people would manipulate the data to try and make the model produce a certain output. And I guess that would be the red team domain. This is probably where a lot of red teams are leaving at the moment.
Yeah, and we're seeing a rise of red team tools within this space. Red team tools for adversarial machine learning. So there's a lot of great open source packages to learn more there. For example, Microsoft has one called Counterfeit. IBM has one called Adversarial Robustness Toolbox. Short, it's called ART. So that's on the adversarial side. And then even on the supply chain side, I brought up an example of the ML flow LFI, RFI exploit There's open source tools to be able to scan for that, see if you're susceptible to that exploit. One of them is called Snake. It's spelled SNAIKE. So a little play there, if you will, of AI. And so there's a rise, if you will, of AI ML red team, all within large enterprises. And we're seeing more and more of those functions come to fruition, if you will, and being built just even in the last 6 months.
So this is one of the longer episodes already, and I think we're sort of barely scratching the surface of this brave new world, which clearly would be on a lot of our minds. Maybe as we conclude here, I'd like to ask for a couple of future predictions, one a bit more concrete and one maybe casting your eyes further out. The first one is just maybe a little bit on the state of audit and where you see that happening. You've referred to audits a variety of times. What are your expectations in terms of what will happen with auditing, use of AI? How quickly should people be prepared about it? What do you think the auditors would focus on early on? What's your sort of sense there? And then we'll go to a more future-looking question.
As we're seeing these policies come to fruition in the EU, here, in the States, it's going to be a forcing function around audit. And what we're seeing on the practice of audit is some of the big auditing firms, consulting firms, are starting the early days of building a practice to audit AI decisions and systems, just like they're auditing financial data and financial outcomes. And so this is going to be a forcing function for these pillars, if you will, of MLSecOps to be able to understand from a place of how these models were built, how and why they're making the decisions that they're making, that true attestation and understanding of the supply chain in the form of a bill of materials. All those things are going to be super critical to be able to adhere and comply with the regulations that are coming in and the third-party auditing that is going to start to grow as an industry. We're already seeing a lot of small shops, and the big ones are coming, and it's 100% going to be a thing as it relates to regulated industries. And so that's something to watch out for just in the next, I would call it 12 to even 18 months. We're going to be seeing announcements in that space.
That sounds very likely given the level of interest in the space. And I guess that comes back, like for you to be prepared for that, comes back to your recommendations around GRC and getting your act together and knowing what's where. I think that would put you in a much better position to answer audits and pass them. And I guess one last question before we let you move on here. Where do you think all of this is headed? If you sort of roll forward the next sort of 3 to 5 years of our dealing with AI security, is this a mess that we're going to be in for a decade where we're going to be chasing our tail and not really succeeding, is like this insurmountable challenge? Do you think it's more of a year of scrambling and then maybe we're in a slightly more sort of stable or as stable as we are with any new tech type solution? And how do you see things play out over the next few years?
It's going to be a year of learning and understanding. And here's what I mean by that. Learning about what's different in these ML systems and these AI applications. Understanding how do we connect the dots to systems and processes and practices that we've already adopted within a large enterprise. And so there's a massive solution ecosystem around security. And I'm not saying that we absolutely have to create new things in that, but we need to connect the dots in terms of what might be standards within security that we see. OWASP standards, as we look at access control, secure design, configuration, auth, there are ML equivalents. So we need to understand the differences. We need to build those bridges. And we need to just put the best practices in place and policies that we understand, in typical software development, but perhaps are not applied or slightly unique or nuanced in the machine learning development lifecycle. Now, I will make a prediction here, and this might be unfortunate. I do think there's going to be a seminal moment within AI here shortly. There will be a Log4j, SolarWinds moment in this space, and the risk is high. If, again, machine learning and AI applications sit at the heart of a company and is used throughout every single aspect of the organization, that is a massive opportunity and a massive threat vector that we need to take serious, and we need to protect it commiserate to its value.
Unfortunately, I agree there's going to be some watershed moments that lights a few more light bulbs for the ones that haven't done it. Hopefully, the ones listening over here will be prepared and will be sort of well organized. Ian, thanks again for coming on to the show and helping all of us organize what this sort of MLSecOps domain is all about. And I think everybody's got a bit of homework to do. So thanks for sharing the views here.
Thank you very much.
And thanks everybody for tuning in. I hope you found this interesting and that you'll join us for the next one.
Thanks for listening to The Secure Developer. That's all we have time for today. To find additional episodes and full transcriptions, visit thesecuredeveloper.com. If you'd like to be a guest on the show or get involved in the community, find us on Twitter at @DevSecOn. Don't forget to leave us a review on iTunes if you enjoyed today's episode. Bye for now.